Good morning, everyone. My name is Edwin Bocardo. I would like to begin to thank you the opportunity to present our job in the prestigious event, taking into account that the current circumstances is very difficult because of pandemic all over the world. It's increased the merit of this event that we are very honored to participate in it. The job that we have carried out is entitled Determination of the Habit Preference Curve of Griffith Cementerios in the Tambo River. This work was made in 2019. We consider the importance of the biodiversity of southern Peru, in special take this stream, this river stream. The scientific name of that is Griffith Cementarius. We can look that in this picture. This is a male. I know that because one of the second leg is bigger than the others. This is the characteristic of the male type. The study that we made is a relationship with the stream, not exclusive, but relationship with this river stream. What is the reason to me for this work? We have two reasons for do this work, for did this work. First of all was the determination of ecological flow. In Peru, we have a law that is the water resource law that established the priority of water use. The first place is the biodiversity. The second is the populational use. The third place is the agriculture, and then is the industry and the mining. So the problem is how can measure the quantity of water that we need for protect biodiversity. The method for do that is the determination of the ecological flow. In Peru, we have an authority that is in charge to make this. It's called ANA, Natural National Water Authority, AMM. Anna says that the better method to do that is an holistic method. Holistic method is a method that considers biological variation and hydrotopography too. So one of the needs for this method is the habitat preference curves of indicator species. Other side, we have to make data for hydrotopographic data. So these two information goes to inside the software, which is physical habitat simulation software. FATSIM is the name. That is free software. You can find it free in the web. The second reason for this job is to take the own knowledge of the own species. Griffith cementarius is an endemic species of this area. This is that only exists from the north part of Chile to the middle part of Peru. There isn't in other part of the world. Besides, it's important because it's taking out but some people, some families, and spend out to prepare dishes for it. So it has important economic and social aspect. That is the reason that the all our knowledge that we have about this species is very, very important and interesting for us. The method that we use to determine the preference curve is the instant flow incremental methodology, IFIM. This methodology needs first place the indicator species. For Tambo River and for all rivers of Peru, this indicator species is Griffiths caementarius, the stream, the river stream. That's because one is a main part of the trophic change. Then is important for the economic and social aspect, and because of the number of individuals into the rivers is a very abundant in the river. The EFIN models have to calculate the habitat use index and the habitat and liability index. So these two, as we see later, these two index we divide it and obtain the habitat preference index. We'll then construct a graphic, upload, and have the curve, the curve of preference habitat for this shrimp. The field activity will carry out from August 2017 to December 2018. For the determination of the habitat index, we find the collaboration of eight shrimp fishermen. They go into the water in the river, put in a line, equidistant separate, and go against the flow to catch all the shrimp that they can. So in the place when they catch the shrimp, it was marked with a plastic bag attached to the ball, technopore ball. This technopore ball float over the water. So our assistant go then, you can see it in the picture. In every place he had to measure depth, then a total velocity that is taken in the middle of the column of water, and flow velocity that is taking the bottom of the river. We, in this point, have to remember that the shrimp is a bentonic species. That's it, that the individuals go in the bottom of the river using the rock to the substrate, the rock, to protect from the force of the water. We take 1,810 shrimps in all this period from 2017 to 2018. We measure depth, total velocity, focal velocity, and substrate. For the substrate, we use this chart of there that take the measure of the rocks and classify in order this measure, this long of the every rock. Then we have to calculate to the habitat and liability index too. For this, we take a river different parts, trying to choose a flat place, a rapid place, and then fix a transect. So every transect was take points every 5 meters. In every 5 meters, we measure depth, total velocity, and substrate too. All this data is a note to them to proceed this data. This habitat liability index try to show how the river offer to the stream, and the place that the stream choose is the index, the use index. So for determine the preference index, we need to divide it both index to say the all the river offered what part is using by the stream. This is the logical of this method. So for the data proceeding is so easy. We have a frequency distribution for depth, for total velocity, and focal velocity. In this chart, we saw the frequency, is the absolute frequency of every measure. It's an example. We have the 1,810 streams catched. So we choose the biggest frequency here, and this is equal to 1. So we divided this by the same value, and we had 1. Then we divide each value from the biggest one, And we have the index of use or use index. They're all the values that we have from use. Then this value will be plotted so we can show a curve. No, for the substrate only we have to calculate the percentage of every substrate. For the percentage of every substrate. As said before, the calculation of preference index, habitat preference index, is divided habitat use index against the habitat available index. This we use to calculate the habitat preference index. The data is presented as the same. We have now the results. The results. Oh, so easy. See the results. You don't know how work get for this data. So we have this curve is a habitat use index is plotted. So we saw the first graphic. As we note, the more common, the more frequency, that is 0.45 meters. No, but we saw that the distribution is very large. So is distributed from zero point 0.1 meters to 1 meter. So is important. The string use this depth for life. So about the total velocity, we know that is 1.79 meters per second is the more frequency, but we have to a big distribution from zero point 0.1 to 1.5 meters per second. Is a long range of velocity, but is one of the main factors of establishing the distribution of the stream. And the focal velocity, that is the velocity in the real place where the stream was found, we have a 0.30 meters per second. We have two distribution of the data, so the biggest number is around the 1.1 meters per second. We have two the substratum, so one is bigger than other. Cantos, equal cantos, unlich, no, is near the rocks. Only two type of rocks are found in this river. Sorry. In the availability index, we have in the depth 0.52 meters, the more common value, and total velocity 0.69 is the same that we find in the use, as you note. No? M is the same too for subtract too, for subtract. Then with these two values, we calculate the habitat preference index and make the graphic is the curve of you. And we have that in the depth, the preference is near the 0.28 meters, but is a long distribution too. And the total velocity is 0.11 meters per second. This is per second. Here on the substrate, we have to make a graphic too to get it in the fab sim. If we can in graphic, we can enter the fab sim. So then the product of this job, the preference curves, is an insum, is an input to the FabSim software. If you put then EGRAX model, for example, then goes into software and calculate the ecological flow for the site that is hydrological model made. No? It's important for our biological study that know that this data is used for flotation distribution of our stream. In Peru, we have a very high, a very popular use of for the milk. So Arequipa gives for this popular meet our chupe de camarones, show them, that is a delicious dish for the own people and the visitors. So I hope that soon and soon we can come to Arequipa and eat this delicious dish. Thank you very much.